let's go ahead and get started. Thank you for coming today. My name is Lee DeBaillie, and I'm the program director for the accelerated master's degrees here in the College of Engineering at the University of Wisconsin-Madison. And before I start, I just want to let you know we will send a follow-up email to each of you after this presentation that will have a copy of today's slides and also a link to a recording of the presentation. If you missed parts of it or you just want to hear bits of it again, you will also get that email. So let's go ahead and get started. One of the first things I want you to think about today, all of you who are here listening to me this morning, and those of you who are listening to this as a recording, you're all interested in graduate school for some reason. And I welcome you to think about why that is. Why are you interested in graduate school? Whatever that reason may be, it is probably your first and best guide to what kind of graduate program you should be thinking about and thinking about applying for. Some examples that are common among students are just pure intellectual exploration and development. Some people want to get very particular technical expertise in a specialized topic. Maybe as an undergraduate, you found a particular area in your engineering discipline that you just really liked and you'd like to study it more and you'd like to get a job in it someday. Getting the job you want, some engineering jobs require engineering master's degrees. Some don't require the degree, but probably require the expertise to even begin. And finally, a big one is doing research that interests you. If you have an interest in research at all, that can be one of the first decision points in thinking about graduate school. For example, if you are very, very interested in research, maybe you are thinking about a career as a professor, or maybe a research engineer at a large research laboratory, maybe in the private sector. You might want to think about a PhD degree versus a master's degree. And we're not going to touch on PhD degrees further in this presentation, but know that that might be best for you. Following that, if you have a small amount of interest in research, maybe you're not sure if you'd like to do it, maybe you'd like to pursue applied research, you might want to consider a master's degree that is focused on getting you ready for the research world. Here at UW-Madison, in the College of Engineering, in our on-campus master's degrees, we have two main types of on-campus master's degrees: research master's degrees versus professional master's degrees. Here in one more slide, I'll get into the details of what the differences are between those two groups. But know that obviously you're going to do some research in the research master's degree, and it's going to prepare you for that field. Professional degree is more getting you ready for working in industry and probably the private sector. One thing to note about UW-Madison College of Engineering, our professional degrees, our professional master's degrees are all accelerated master's degrees, meaning you can do them in just about 12 months. And so sometimes you'll hear these referred to as accelerated master's degrees, sometimes as professional. Comparing the two types, both research and professional you take classes, you're in courses. Uh, in professional, you have to take 30 credits of courses. In research, you might take 15 to 20 roughly credits of courses, and the remaining credits up to 30 would be from performing research, typically with a faculty member and often with other master's and PhD students. So you take more courses in professional. In professional, you don't do any research. Obviously, you do that in the research master's degree. You document your research findings in what's called a thesis. None of that is performed on the professional side. It's purely courses, 30 credits of courses. Both research and professional are here on campus in person. With respect to funding, there's a big difference. In research, you have a chance at getting an assistantship, be it a teaching assistantship or a research assistantship. Those can provide a monthly stipend, like basically pay like you'd get from a job, and they can also waive your tuition expenses. On the professional side, we don't have those. You can get an assistantship, but you only earn the stipend part, the part that's like getting paid like a job. You do not get a tuition waiver or an assistantship in the professional programs. They are self-funded. Generally, as I said before, if you go with a research master's, you're probably shooting for research in academia, possibly in industry. Professional degree, you're shooting for industry. Both master's degrees can increase your earnings right away in the workplace. Some positions require master's degrees when you start out. Both of these types of degrees would work for that. Little difference in how long it takes to get it. At UW-Madison College of Engineering, a research master's degree, the mean time to get one is about 2 years. Most finish in that 1.5 to 2.5 year range. To get one of our professional accelerated, the mean time is about a year. You might have to extend that for various reasons out just past a year. So you get in and out faster on the professional side, and you don't do research with the professional degrees. Let's take a quick look at some of the programs available with the professional degrees. We have 12 of them currently, and I'll just very briefly touch on all of them. And you can find more detailed information, and you, Lee, if you would insert a link in the chat to the PDC website for our programs, in particular our accelerated programs on campus in engineering. We have a civil and environmental engineering degree that's professional. It has 6 areas of study. It's designed to be fairly flexible in the courses you take and the area of study you choose. You can start in that in fall and spring. We have 2 in electrical and computer engineering. One, like civil, is called professional. It has 9 areas of study, and it only starts in the fall. The other is called machine learning and signal processing, which is kind of self-explanatory. It also has a fall start. Our engineering mechanics department has an aerospace master's degree. It has a fall and spring start. By the way, all of these professional masters are Master of Science degrees. We have 2 biomedical engineering degrees. One's called the accelerated program. It's much like what we were calling professional on the last slide. 6 areas of study with a fall and spring start. We have another biomedical called Biomedical Engineering Innovation Design, and that should say entrepreneurship. It is focused on primarily product development within the biomedical area, and you take some business courses in this particular degree program. Under industrial engineering, we have two. One is focused on human factors and health systems engineering, fall and spring start. Another focused on systems engineering and analytics, another fall and spring start. Finally, material science has a materials engineering program. There are two areas of study. One is in nano materials and nano engineering, and the other is in engineering materials and processes. That has a fall and summer start. And then finally, we have three programs in mechanical engineering. One is an accelerated 6 areas of study. We start all terms with that. One is automotive with a focus on engines, in particular combustion and thermal science. Fall and spring start for that program. And finally, we have modeling and simulation and mechanical engineering, all three fall, spring, and summer starts for that program. All of these professional accelerated programs are face-to-face on campus. All of them require 30 credits of classroom instruction. If you are getting your undergraduate engineering degree from the University of Wisconsin-Madison, you may be able to apply 6 or 7 credits from your undergraduate degree towards your 30 credits and actually reduce that number to say 24, 23 credits, saving money and actually potentially reducing the amount of time to 9 months to a master's. If you don't have that, the time frame is typically in the 12 to 16 month range. Our tuition is $1,200 per credit plus fees, and the fees run from roughly $300 in the summer to about $800 per term in the fall and spring semesters. A little on the requirements, and I'm going to talk about general requirements that cut across all the programs. Each program will tend to add a handful of specialized requirements on top of this. And you can see those requirements both in the link that UW is providing, but also in what's called the guide, in particular the graduate guide here at UW-Madison. And if you would provide a link in the chat for that, please also, UW. You can burrow into each program and see what their additional requirements to these general requirements are. Anyway, the general requirements are a bachelor's degree from an accredited institution. Some of our programs increase that to an engineering degree. We do have a minimum GPA of 3.0, and that's a strong requirement across all the programs. A handful of the programs have a preference for a GPA higher than that. We used to require GRE scores. At present, for the terms from now through fall of 23, we are not requiring the GRE for any of our programs. If you are not a native English speaker, you may be required to submit English language test scores. You can find more details about that in the URL in the lower right of this slide. If you received your undergrad in a primarily English speaking school, you do not have to submit the test scores. Note that our deadlines for application differ a bit depending on which term you're looking at starting in. In particular, if any of you listening right now are interested in starting in the spring, in other words, in late January of 2023, note that the deadline for application is October 1st, which is just a few days away. So if you really want to do that, you'll need to get moving. Otherwise, however, for next year, for both summer and fall, the application deadline is this December 15th. Primarily what you need to apply for these master's degrees are to fill out a graduate school application. You'll need to submit a resume. You'll need to write a relatively brief statement of purpose, which outlines why you're interested in going to graduate school. And there we go right back to slide number 1. Why are you interested in doing this? What's your purpose? We also need you to upload copies of transcripts that you have, which we call unofficial. Later, you would be asked for official transcripts, which need to come directly from your educational institution. We also ask for 3 letters of recommendation, and I highly encourage you to start early in thinking about who you might ask to be a recommender for you. It can take some time to work through getting permission from those people, thinking about who would make a good recommender. So I encourage you to really start early on that one in particular. Just a little bit of return on investment and why you might do this, and a little bit financially speaking. So it's 30 credits. They're $1,200 per credit. So tuition wise of these master's degrees, and I'm talking about the professional accelerated degrees, run $36,000 for the full 30 credits. Plus the segregated fees might be another $2,000 roughly. Another advantage is you get plugged into UW-Madison's worldwide alumni network, including the College of Engineering's Career Center, and some of our events for meeting with employers from around the world. Below is national data for engineering master's salaries. We have a study here at UW-Madison where we compared a cohort of bachelor students with bachelor's degrees with a cohort of master's students, engineering degrees, 1 year out of school. On average, across all disciplines, the master's students made approximately $13,400 additional income per year by having a master's degree. So that's roughly speaking a 3-year payback time to pay for the tuition and the fees for obtaining the master's degree once you're out and employed. That's the end of my presentation. I wanted to keep it short to take time for questions. This final slide has my contact information on it. If you have any questions that occur to you later on, please note that the email you receive with the slides and a link to the recording will also have contact information for our enrollment coaches who can help you with questions about applying for these programs.